What is up, everyone? How is my favorite audience doing? We are back again with some serious game development upcoming here. So, what are we gonna do today? Well, first of all, let me take off these headphones. Second of all, today I hinted, when I last left a preview on the previous episode, I said I'm gonna do animations, and I think that's what I'm gonna be doing. Now, we do have a couple of things in here that should be animated, right? Like the projectiles, like I think these are like spinning, right? What else do we have? We have like the enemies, they're animated, right? And so, yeah, we are gonna do that. Let's get started. Okie dokie. Let's create a header called animation. And I don't know if we discussed this last time, but we basically want to replace, in some objects at least, the okay, it's not here. I think it's the entity. Yeah, no, okay. Oh, it's just that, okay. Well, some objects have the texture, not all of them have a texture. So we want to replace these texture details with an animation. So, how are we going to do that? Well, that shouldn't be too hard. Talking about voice cracks. The king of voice cracks is here. I'm back again in town. Let's see, animation. And what is an animation, guys? An animation is simply a sequence of texture, basically, and each frame should technically be on screen for a set amount of time. But in our case, all frames will be on screen for the same time. It just makes it, way easier. It's not that big of a deal. But yeah, I mean, look at what game we're working on, guys. Like, did we see our project? Like, does this look like it has to be done in a certain way? No, it doesn't. So yeah, we are doing what we deserve. So, let's see. We need a, I don't know, like a vector of texture details. Frames. And we also need the texture details. And we also need here like a float m time per frame. Here we need well, we need a way to add frames to this animation. So we maybe will have something like add texture, I suppose. I'm thinking really hard. Yeah, whatever, add frame. And it's simply going to be a texture detail frame. We are not going to be doing it here. We also need a way to tick the actual animation so we can update the time, and we also need a way to render the animation. And I suppose we will have a default. So let's create a source file, please. Always say please, guys. Okay, nice. Let's put it in here. Include animation.hpp. Let's see what we got. We need yeah, actually let's do it like this and say, well, m time is 0, m time per frame is 0, and we need some functions to set these to. I think I mean, we can change this at any time, you know. Set well, we don't actually have to set this time from outside, we only need to set this side, like the time per frame. Set time per frame, float time, and we are gonna implement that. So bada bing bada boom, we have m time per frame equals time. Pretty nice. Let's actually add all of these. We already added that one. So this is what we have left. Just like that. And what we are going to be doing, obviously, is m frames push back frame in here. We simply add it there. Here for the rendering, we should give it like a position. I was thinking about it, and the size for now. We might add in more stuff in here later, but for now I think that's enough. And we also have to include our amazing math library, math function. And okay, let's see what happens when we tick an animation. How do we update an animation? Well, we have this time that advances, right? Delta time, and we know when this float becomes like 1, 2, 3, it means like 1 second passed, 2 seconds passed, and so on. And using this, we can actually compare the m time with the m time per frame, and when this m time exceeded or is equal to this m time per frame, we are changing the frame to the next one. So if m time is greater or equal to this, we're gonna reset this, so we are back to 0, so we can count again until we reach this. And what's gonna happen is we are gonna say, we also need a way to track the current frame, so just like that. So the current frame is always 0. Well, it can be -1 in the beginning actually, because it's invalid. So m current frame, we simply advance it, but we have to clamp it to the size of our frames vector here, right? So we can't go over and say the current frame is actually outside of this vector. And so I'm gonna use this modulo here using the size of the frames vector, so it can't exceed it. So next thing, well, this looks to be quite alright. Not gonna lie to you guys, this doesn't look too bad. Yeah, so let's see. We are gonna bother with the rendering maybe later. Well, actually, let's make it now. I suppose we can take this, put it in here, and we have like the destination Well, first let's include Raylib. Raylib, thank you. And I love it when Visual Studio just pauses like, for no reason. I just love it. This, and this. Just like that. Texture, well, we don't have that. We have to take the current texture from the frame, so current frame, and the same is gonna happen here. Destination, origin 00, white, whatever. Okay. So technically now we should be able to have an animation. Now we need a way to load in these animations quickly. And what I'm thinking is we have something like assets load asset animation. And what we have here is we give in like the path to the file, like this Alan thing, which we already have here in this one. Come on, pretty long one. I mean, we are referring to the string, obviously. We specify how many frames we have, and so and guys, we are improvising here, so yeah, we have 1, 2, 3, 4, 5. I don't know if these are like two different animations or just one animation. We can test this out, but for now let's just animate this whole thing. So we have 1, 2, 3, 4, 5, 6, and let's do this. We have 6 animations here, and they are 16 by 16. Okay, so using this information we should be able to load in each texture sequentially, like one after another. And let's see, if we go into the assets thing, if we go down here, void load asset animation. Oh, okay, that was what I copied. We need this path. Oh, we also need to give it a name. Yeah. Frames, width and height. And let's go back here and give it a name. Alan animated. I don't know, idle. Just like that. Let's go back to the assets. And what is happening here is we need to load in this texture actually. So we have to do the same check as in here, because when we load an animation, we still have to check to see if our texture is already in memory. And so what's gonna happen is we also need here a static map of animations. And it doesn't know who this animation is, and so we're gonna tell him. Great, and the result here should be an animation, just like that. Oh, we also have to specify the time per frame. Completely forgot about that. For now, it's gonna be like 0.1, so 100 milliseconds per frame. All good so far. So what's happening is we test to see if we have this texture. Animation texture. So let's see that. And what seems to, oh, Oh no, actually I don't know. Let's see. Oh, this is okay. So the texture here needs to be like that. Yeah, I forgot that's not the actual texture we are loading. And well cached, we are adding it. So that's all good. Okay. Now we need to load this animation. If you remember, we have this source rectangle here, which in our case, we can set it here to the full thing. So we have 0, 0. Well, yeah. Not so sure about that actually, because now we have to actually pick up the draw, I think. So we have to we have this image, and what we have to do now is instead of saying this is the image, we actually have little images in here, and so we have to load these as separate textures. Okay, so what we can do, it should be pretty simple actually. All we have to do is store multiple texture details, and we just change the X, Y, width and height. So the width and height, we know they are given to us here. And let's see, we're gonna make a loop here. Now we should need some error handling in here to see that the image actually has as many frames as we claim it has, but that's a problem for someone who will actually fix our bugs, and that is us in the future. So we don't have to worry about that now. So X and Y is well, we are gonna pretend like our textures are always in a like horizontal sprite sheet, like this one, like so it's one next to each other horizontally. So we are gonna advance the X coordinate. So int offset, and we don't actually have to do that. We can just say this. Okay, so the X is always the frame we are on times 16, and this should actually jump correctly from one texture to another. And what's happening is we are actually creating here a texture details frame, and this frame has the texture, the animation texture that we just established up here, what it is, the one that we loaded. Frame dot source is actually this source. That's from where we take the image from inside the image. So this region over here, and now I don't think we have a destination here. No, that's it. And what we need now is this result, which is our animation, to add this frame. Okay, and we also need, we are actually gonna do it up here. Result dot set time per frame. We have here time per frame. Result. Okay, that's it actually. That's all we should need theoretically. Now let's actually add this animation to our map, and we should be good to go, guys. This looks pretty promising. Doesn't look like a complete mess. No, why would you say that? Stop saying that. Okay, Good. Let's see if our little non-static member. Oh, we forgot to make it static. Nice. Okay, let's go into our enemy. And actually, enemy. And instead of a texture, let's make it have a animation idle or something. Assets. And we need a get animation function, which we forgot to do. Animation Alan idle. Alan is the name we took from the file. Let's go in here, assets. No error checking, obviously, because we are just that good. Things work out of the box. Animation. And we're simply going to return animations name. So in our enemy, we actually have to tick this our current animation. So well, we could have like an animation. So if the enemy is changing like the state, it should typically change the animation, but for now we only have one animation, so let's just tick that one. Delta time is passed in here, and I think we have to include the animation. Just like that, and instead of rendering an actual texture, we have to actually render something else, which is idle render position, and we have like 64 by 64 size, which we decided on. Let's see. And well, out of the gate it just doesn't work, so that's promising. Let's see, what did we mess up. Current frame is -1. Great, so it didn't get to change. That's normal. So let's do this, shall we? So if current frame is different than -1, we should do it. Okay. Well, actually, let's make it prettier. I like this style a lot less. We have this early exit that we are doing. And also this doesn't seem right. We should initialize the current frame to something. So if we have at least one frame, we know we could initialize this to 0. Okay, so we see this enemy is animated. I don't know if it's the correct animation, but hopefully you can see it. We can make it go slower, because I don't know the YouTube gods what they're gonna decide on my video. Some things might be less visible on YouTube than they are in reality. So let's make it 10 times slower, and here it is, our little boy getting all animated and excited. And yeah, now we can have animated stuff. Oh, and we also have to pass in the color argument. Let's do it now. Let's do it now. Let's pass in the color. 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 And we go in here and we say, hey, we have a color for you. Color. And it's no longer this one. So we go into the animation.hpp. And by default is white, because this means the texture doesn't change. So let's see, now it should get red whenever we hit it. And it does get red, guys. It does. Pretty nice. Let's add in actually. So this is bonus, guys. This is how much I care about you guys. This is how much I care about my community. I'm gonna add a bonus thing this episode. Let's add in, I've seen this effect, this explosion. Let's add this in. What do you say? Let's add it so that when an enemy dies, it's gonna explode. I'm not sure if that's how the effect is meant to be used, but at this point I don't even care, guys. I'm doing anything just for you. Effects, effects, and it's called explosion. Explosion. Okay, explosion. It has 4 frames. 1, 2, 3, 4, 5. It has 5 frames. So let's do that. And it's 16 by 16. This is an explosion. That looks pretty good. Let's create a explosion particle. Explosion particle. And this should be pretty easy. Guys, we are writing stuff from scratch every time. Oh no, this is a CPP file. I don't know why I right click on the header files. I do new item and it says, oh, so you want a C++ file. Okay. Quit kidding around. Class explosion and particle public game object. Why not? Let's write it all from scratch because we have time to waste. So include game object. Nice. We need also an animation. Good. Let's actually, well, we might have other particles in the game as well. I don't know now what particles, but maybe. So we will probably take this out in a separate class and make it this explosion particle to be derived from that class, like a particle class. Well, anyway, I'm just talking, nonsense. So let's see. We need here an animation, like the idle animation for the particle. I just think it makes sense like that. I don't think we need too much else. We need also particles need to disappear after some time, so we need a lifetime. And we need here a scene and a position, and that's it, I think. Wait, what's the error here? Oh, it's from Raylib and it doesn't even know. I mean, it did because it built, but it's Visual Studio. It's, somehow it's the way it compiles. It's not how it parses this in order to check for errors. So yeah, and we also have to specify here like the lifetime maybe, but maybe typically we know an explosion particle how much it will take, so we don't have to customize this. So let's create a new explosion particle. Well, we could, this explosion particle, this feels like we could just add in. It's so small, the implementation is so small. I think we can just add it here. Don't you think, guys? Float delta time. Because otherwise, for every single particle, like for every 10 lines of code, we have to create 2 new files. This is why I hate this structure. We have to write a lot of code for, basically nothing. So that gets annoying pretty fast. We are gonna tick this delta time. Guys, you can just sue me, guys, again, like no issue. Just sue me, say, hey, we don't like how you are making the game. Make it better, and I'm probably not gonna do it because you're probably not gonna sue me, and that's it. Okay, I'm talking nonsense here, guys. Let's see. I mean, in case you couldn't tell, get animation. Let's see. Let's include the assets here. I swear God, if I start a podcast, I'm gonna be arrested or something. Explosion animation. This is how I called it. No, it's just explosion. Let's make it. Although, yes, I know it's get animation explosion, but still. And lifetime, let's say it's 1 second. Good. We say lifetime. We decrease the delta time from it, and so if lifetime is less than or equal to 0, we are simply gonna delete this object. Delete. Nice. Let's add in the render function, and we are simply gonna copy with no shame. We are simply gonna copy this with no shame. mcal, let's just make it this. And now what we have is in the enemy, in the death thing, we're actually gonna delete this object and we're gonna create this explosion particle over there. So I'm seeing, and this is very typical, guys, in games, in case you didn't know, creating these particles which are completely different objects just for, you know, visual effects and such. And so, oh well, we also have an advantage because Raylib, I believe, uses texture batching by default. Well, not texture batching, but quad, well, batch rendering by default. So it puts a bunch of rectangles together in one buffer, so it gets rendered faster by the GPU. It gets sent faster. Well, not sent faster, but processed faster than sending all the rectangles one by one. That's called batching. And this is by default up to I don't know how many rectangles. And so if we have a lot of particles, Raylib is actually going to help us with that because it's going to render them very fast. Because this is how you want to render particles. You have to batch all of those like 100,000 you know, particles on the screen at once, basically. So yeah, let's add a new explosion particle, which we didn't initialize at our position. And let's include it here. Flow particle. Let's see if it works first time. What do you think, guys? Is it gonna crash or is it gonna work? Well, I don't know what to say, guys. It seemed to me like it worked. The only issue is that the animation got to repeat itself twice before it actually disappeared. So let's have something better. Instead of having a lifetime, let's create a callback function for which for when the animation finishes. And so we know when an animation so we know when an animation finishes and we get called a function and everything is fine. So let's go into our animation. Oh, here we are. And let's say let's just create like a function here. We can do it in more ways. Let's see. For now, let's not take anything with us. Callback. This, I believe it was in functional. It's been a while since I've done, since I've used the std function. So let's add here a set and callback, or just callback animation and callback. Why not? Doesn't sound too bad, actually. Sometimes just use longer names, guys, if it's more descriptive. Why not? It's better that way than call it a shitty name and then reverse engineer your own code at some point. M callback is simply going to be the callback. Okay, and here, if after we advanced the current frame, we had to reset the so what happens is, what I mean is, this current frame will be 0, 1, 2, 3, 4, and then when we hit 5, it's gonna reset back to 0. And so if we reset back to 0 when we actually increased it here, it means we looped around, right? Because here we increased it to 5, we did a +1, but we had actually 0. Okay, and so if this current frame is 0, it means we actually ended the animation once. You know, at this point. Well, or multiple times, but we just ended the animation, that's it. And if we have a callback, we can just call it. Okay? Just like that. It takes no arguments because we are going to use lambda functions, most likely. And that's that. We can change this in the future if we want, but yeah. Let's go into the enemy. And no, not the enemy. The explosion particle. And instead of having a lifetime here, let's just say, hey, idle, we need to add in a animation end callback, and we are going to use a lambda function for it, and we are going to actually use this. We're going to take this with us, and we are going to call delete. Okay, and let's see if this worked. It should have, and it did. Okay, this is sort of called like event-based programming. Like we only do stuff on events. Like we didn't check every frame to see if we have to delete it. We only did it when the animation actually ended. But yeah, so I think this is it, guys. We have to say goodbye one to each other, one to another. So what the hell am I talking about, man? See you in the next episode, where I don't know what we are gonna be doing. Maybe create more enemies, maybe more effects. I'm not sure. We will see. Goodbye.